So what we're going to do now is we're going to talk about an example of how to manage the Java thread lifecycle. And this example is found in my GitHub repository. You can find it under my interrupted folder in the GCD example. And this will illustrate how to use interrupts in the context of multi-threaded programs. So what we're going to do here is we're going to use a thread to compute the GCD of two numbers. I'm sure you all know probably from 7th grade or 5th grade or something like that, that the GCD is the largest positive integer that divides two integers without having a remainder. And what's interesting about this particular application is that the user can interrupt the GCD computation at any point along the way by clicking the interrupt button. And you can see here it'll basically stop the program. So this app showcases Java's ability to start and interrupt threads. So we'll look at start and interrupt. And there's a couple of different pieces to this. There's a class called the Lifecycle logging activity that automatically logs lifecycle hook methods. And this is intended to be able to make it easier to debug your program, because you can see the lifecycle operations that Android does when an activity is going to start and stop and be paused and resumed and so on. There's the main activity that's the main driver program for this whole thing. And then there's something called Gcd Runnable. And this is the computation that runs a thread and repeatedly computes the GCD of two random numbers, and of course can be interrupted. So let's go ahead and switch over and take a look at how this code is implemented. So here's the implementation of the Gcd Interrupted App. As we saw before, there's this thing called the lifecycle logging activity, and it's just basically got a bunch of implementations of the hook methods that Android provides, and it just logs the results so you can see what's going on. Here is the Gcd Runnable Interface. As you can see, it extends the random class and implements runnable. So therefore, it inherits the ability to generate random numbers. It's got a couple of fields in here that are used first to be able to get a connection back to the main activity so we can display the results. And then we have the number of iterations that we want to run. The constructor assigns these fields. Here's the main GCD compute method, which is going to do a recursive implementation of Euclid's algorithm to compute the GCD. As you can see, if the number equals 0, if number 2 equals 0, return number 1. Otherwise, you call this thing recursively and mod number 1 by number 2. And then down here, we have the run method, and that's going to go through all the iterations, generate two random integers, check to see if we've been interrupted using the interrupted method. And if so, we break out and shut down. Otherwise, every so often, we go ahead and print out the GCD that was computed by number 1 and number 2 that were generated randomly. And when we're all done, we break out of the loop and we tell the main activity that we're finished. And then over here is the main activity. You can see we're going to have a default of a very large number up here. It's going to be essentially 100 million. And some other stuff in here I'm not really going to go through that are kind of Android GUI related operations. Let's take a look though at the interesting part, which is going to be the part where we will start or stop the computation. So you can see here, if the thread exists, then we go ahead and call the interrupt computations method. If the thread doesn't exist, then we're going to go ahead and start running the computation. And as you can see down here, here's what start computations does. It prints a toast, creates a runnable command, and then creates a new thread. And it starts that thread running the runnable command. And then down here, you can see that we have another method called interrupt communications, or computations rather. And when this is called, this is what will be called if the user clicks the interrupt icon. And then that goes ahead and interrupts the GCD thread and basically tells the user that we're shutting down. Okay, so when we're finished, then we basically go ahead and tell the program to shut down as well. Okay, so let's go ahead and take a look and see what happens when we run this program. So you can see now here's the Android emulator, and we're just going to hit return. So it's going to run for a very long time, 100 million operations. And it's off to the races, running. This could go on for a while, of course. And whenever we're tired of running the computations, we click this little button, and you can see it goes ahead and stops right away. and then will cause the interrupt to be handled, which causes the GCD Runnable to detect that because it's checking to see whether or not it's been interrupted every so often, or actually every iteration it checks to see if it's been interrupted, and then it shuts itself down. So that's illustrating a nice, simple example of how you can integrate interrupts with an Android app in order to get the program to responsibly shut itself down when you don't want to run the computations any further.